Hey everybody. Today we're going to jump in. You can see the title on the screen. We're going to deal with Geometric Figures Part 2. So this is a follow-up from when we went through and we introduced going through and dealing with some proofs, verifying certain quadrilaterals and triangles. Today we're going to pick up from where we left off. So you're going to see our first problem called number 5, and we're going to continue on from there. Okay, let's jump right in. So let's take a look at the problem on the screen. I want you to pause the video, give it a read, and I actually want you to jump straight in on this one. I think because this is day 2, we maybe have a better grounding for what we're working on. I think we could probably give this one a good shot, okay? So I want you to pause the video, give it a shot on your own, okay? Pause it now. Okay, we are back. So if we are working our way through on this one, again, I'm hoping pretty automatic. I'm going to be pretty quick, though, in terms of diagrams. So if I was to draw my diagram off on the right today, doesn't matter where I draw it, point A, which would be at 4, -5. So if I went to the right 4, then down 5, I want to make sure that my point looks like it's a little farther down than what it was across. Point B is at -3, -4, so that would put it somewhere around there. And point C is at 5, 2, and I think if I was to put things in those positions, everything's relatively proportional. Okay, it says verify that point A is on the perpendicular bisector of the line segment BC. So if I'm going to go through and I'm now going to create a line segment BC, I need to make sure that I am connecting those. And what the problem asks me to do is to verify that point A is on a perpendicular bisector of that line segment. Okay. If we had any hiccups with our sketch, then this becomes an opportunity to pause the video and try it on your own again, okay? Otherwise, you're coming along with me. So I'm hoping we're good if I just shrink that down a little bit to remind us that perpendicular is going to mean that we have a 90-degree angle, so we should be good with slopes being negative reciprocals on that one. And then the bisector means that we're cutting it exactly in two. That means we're talking about a midpoint. We need to go through halfway. So if I was to now draw that perpendicular bisector on the diagram, I'm going to draw it in orange. That means that I would have to go through on that line segment, and I'm trust my eyes maybe a little bit here, the midpoint of BC. That would satisfy the bisector part. Then I need to make sure that the line that crosses through there, and I'm going to do my best here, would pass through at a right angle, because that would satisfy the perpendicular part. So what I need to do is to make sure or verify or prove that point A is on that orange line. Okay, if we weren't sure what the problem was asking us for, then now it should be clear, not necessarily saying how we do it, but what it's asking for should be clear. Pause the video again, give it a shot, try to see if you can finish it off. Otherwise, coming along with me. Okay, if we are going to work our way through, then I've got a number of ways that I could go through to prove this. What I could do is I could build the equation of that orange line, and then I could show that point A was on it. So I could independently just build that equation. That's going to be probably the most logical way for us to verify that that point is on the line. Like I'm literally doing what the problem says. So what could I do? Well, to build the equation of that orange line, I need slope and a point. Well, my slope is going to be the negative reciprocal of whatever BC is. So if I found the slope of BC, And I can say that I have a rise of 6 over a run of 8. That means the slope of BC is 3/4. What I then know is that the slope that is perpendicular to that must be the negative reciprocal, and therefore negative 4/3. Okay, I have the slope of that orange line. Now I need a point that it passes through. I am not going to use point A for that because that's what I'm trying to prove with this strategy. So what I need to do is I need to find the location of M. I need to find the midpoint of BC. That means I need the average of my coordinates. So I can add together my coordinates, and I'm not going to just blindly plug my coordinates in. I can do a little bit of work here. So I'm going to find the average of 5 and negative 3. So I'm going to add those together. That's 2. Cut it in half because I'm finding the average. Take the average of my y coordinates. That's negative 2. Cut it in half because of the average. If I then simplify both those, then I find that my midpoint exists at 1, negative 1. Okay, I now have the information I needed. For me to go through and build the equation of the line, I needed slope and a point. I have both, so now I'm going to build the equation. So what I'm going to do now is take my slope and sub in my point back into my slope coordinate formula. And now I'm going to write that equation in an acceptable form. So I'm going to multiply out my x minus 1, multiply out my 3. I can now put that in an acceptable form. Like maybe I go standard form. So I'm going to picture everything going to that side because I need my x coefficient to be positive. So on the right side, that would be a positive 4x. My y term is already there. That means I need my constant to get out of there. And there we go. Okay, why did I not write that in slope-intercept? It just would have required extra algebra. I would have had to divide out and so on. But also, I now just need to confirm, to verify, to prove that point A is on that orange line. So now that I have the equation for it, I don't really care what form it's in. Okay, here comes my proof part. So I'm finally getting to my proof. What I could now do is sub point A into that line. So if I sub that point into that line and I can get left side to equal right side, then I know that that point is on the orange line. So on my left side, I'm now going to have a 4 times a 4. There's me subbing in my x value. And 3 times negative 5, subbing in my y value. That gives me a 16 minus a 15, and that gives me a 1, and I'm running out of space on the bottom. My right side in that equation was 1. And so since my left side equals my right side, therefore, A is on the line. And there you go. There would be a solution that I think is the most logical for you to work your way through. If it tells me to verify a point's on a line, then build the equation of the line and show the points on it. It's kind of like going back to grade 9 stuff. We're using our background skills to get there. Okay, there is another way that you could go through and prove that. What we could have done was we could have built the equation of that orange line by using the slope of the line and point A. Now, if you're looking at it and you're saying, but wait a second, we're trying to prove that point A was on the line, what you would now need to do is take the midpoint and show that the midpoint would go through that equation. And now you've proved that it does pass through the midpoint, therefore it bisects with the perpendicular slope, therefore it is on the perpendicular bisector. Okay, the other way you could have dealt with that, though, is you could have found the midpoint and found point A, or used point A, and calculated the slope between those two to show that it is the negative reciprocal slope of BC. Therefore, you would have proved the bisector by the midpoint, and now the perpendicular part by the negative reciprocal slope. Okay, 3 ways you could have gone through to do that. I think the orange solution is the most methodical. It is the one that is probably the most logical. It makes sense. Okay, there we go. There is a full solution to problem 5. Hopefully, we're comfortable with it. Okay, I want to change gears a little bit now on problem 6. Okay, there's problem 6 on the screen. Hopefully, you can take a chance to read it. Triangle ABC has vertices at those points. Now you have to determine the equation for, and in part A, you have to come up with CL. Now, first off, you're going, what's L? There is no L on here somewhere. CL then is the median from C to AB. Okay? From C to AB. So what I'm going to ask you to do, just up in this space up in the top right corner, let's go ahead and let's build a diagram for it. Okay? We're going to produce one diagram, decent size, and then we can use it over and over again for all of our parts. Okay? I want you to pause the video, and when we come back, we'll have a completed diagram. Okay? Here we go. Okay, we're back. We've got our diagram up off to the right, and hopefully we match up. So what the problem asks me for is to go through and draw a median from C to AB. So my median has to pass through the middle, and I'm just eyeballing my middle. And I need to now draw the line that would go from C to that green point. Now, there's a few things on my diagram I can do. Maybe I just draw my median like that. What I would do then is I would need to call that L, because the problem told me that that point was called L because of CL. What I could also do on my diagram is label that both sides of L have that single tick mark to show that they're equal length, therefore L is a median, or is the midpoint. Okay, the question in part A asked me to come up with the equation for that green line, my median. Okay, we're gonna get a lot of practice building equations. What do we need to build an equation? We need slope and a point. What do I know on that problem? Well, I have point C, so I already have my point. Problem is, I don't know my slope of my green line. In order to calculate the slope of that, I would need 2 points, and luckily, I can find the location of L. Because I know that L is a midpoint, I'm looking for the midpoint of AB. And so what I can do then is take the average of my coordinates, my -2 plus 1, and then half, my 2 plus 5, and then half. So now that we have the midpoint, I can now call that point L. So I don't have to label it as midpoint AB, but I could if I wish. Now I have that point. I also have point C. I can finally find my slope. So my slope of CL is going to be, okay, this is going to be a little uglier. I need to have my 7/2 minus my -3 all over my -1/2 minus 3. Okay, I'm going to slide that up a little bit now. I don't really need my diagram. Now I got to work my way through. Yes, this is a little bit uglier because of the fractions. Just take your time. So on top, I need to get a common denominator. So that's going to be halves. So my 3 becomes 6 halves. On bottom, I need to get my common denominator of halves. So 3 again becomes 6 halves. I really want to make sure that I can see my dominant fraction line. There's my dominant division. So now when I go through and I take my one fraction and I divide it by my other fraction, I can now flip and multiply and hopefully now cross reduce, and that simplifies down to a negative 13/7. Okay, so I've only found my slope, which is what I needed to build the line, but I do get a little confirmation. Like if I look at my diagram, my line should have a negative slope because it's going down to the right, and I do get a little confirmation with that. Okay, I'm just gonna move this whole thing up because now down below, I'm gonna actually build my equation. So therefore, my slope, and I have a choice over which point I want to use. I hope everybody is picking point C because of how nice those coordinates are as opposed to the fraction ones of the midpoint. So if I use point C, then I can subtract my y coordinate and subtract my x. That now gives me an ugly equation, but I can multiply out my x minus 3, multiply out my 7, and now just put it in a proper form. I think I'm just going to use standard form and get everything onto the right with my variables because of that negative coefficient. So I'm going to have a 13x on the right with my 7y. That means that I have to get rid of that 21, and I'm coming in on an equals 18. There we go. So if you came up with that, great. Then there is your equation. If you happen to be a slope-intercept person, I'm going to maybe just kind of sideline it like right over there. Then you probably would have went negative 13x plus 18 equals 7y, and then divided everything by 7 and finished off with that. So either of those two solutions are outstanding. There we go. Okay, I think that gives you then an idea of what we're working through for maybe the next couple problems. Okay, so what I really want you to do is to try to attempt the other ones on your own. This should be a really good gauge of how comfortable you are with some of the new concepts, with some old skills. Okay, let's take a look at B. So you'll notice I've duplicated my diagram up on the right. We already have our diagram from before. Now question B wants you to find AM. Again, we don't know what M is, but AM is the altitude from A to BC, okay? I want you to work your way through and come up with the equation for AM, the altitude from A to BC, okay? Pause the video now. Okay, we're back. So if we were going through trying to build this one, then we need to run from A to side BC, but I don't know what point I go through. Because it's an altitude, I don't know the point I pass through, but I know that that green line has to be perpendicular to BC because it's the altitude. Now, I also do know that that point is being called M because of AM, but that's what I know for the concept. So if you have that green on your diagram, then you understand the concept of altitude. Now the rest is just, can you go through and build the equation of that line? Okay, let's pause the video if you haven't, and we'll go through and we'll confirm a solution. Okay, pause it now. Okay, we're back. So again, to build the equation for that line, we need slope and a point. We have point A that we go through. We don't have the slope, but because I know that AM is perpendicular to BC, then that means if I knew the slope of BC, I could find the slope of AM. So I am hoping that we started off by finding the slope of BC. So my rise, I am going my 5, subtract my -3 over a 1, subtract 3. So that gives me, I'm going down 8 with a run of 2. That gives me a slope of -4, and that makes sense looking at my diagram. Now that I have the slope of BC, I know that the slope that's perpendicular, and I could write my little perpendicular symbol. There's nothing wrong with that. I'm going to go one step further here, and I'm going to say, therefore, the slope of AM, because that is the perpendicular slope, has to be a slope of 1/4, my negative reciprocal. And so I could then come up now and build the equation of that line. I know that my slope of 1/4 has to be a line that passes through point A. So if I slub my slope and my point into my point slope coordinate formula, then I am good. I can multiply out to put it into an acceptable form. I think in this instance, I'm going to stick with standard form again. All my variables are coming to the left because of the positive coefficient on x. Sorry, that y got crazy. So let me just adjust that y for a second. And so I'm going to get an x minus 4y. That means get rid of my +2, so I'm going to -2, and there we go. Same thing as what I discussed before, though. Nothing wrong if you wanted to take that and turn that into slope-intercept. So we probably then would have done this and got rid of the -8 and added 8, and now divided out a 4. It does mean that when I calculate my 10 divided by 4, you can see that fraction will reduce. So it does require me to deal with a little extra work and simplify that to 5/2. Okay, either of those, and we are good. And hopefully that one went well. Okay, here comes the last one. Let's jump into C. Same thing as I mentioned before. You can see my diagram duplicated up on the right. This time you have to come up with the equation for NP. Okay, neither N or P are on my diagram. So what is NP? Well, NP is the right bisector of AC. Okay, give this one a shot. I think we should be good with it, okay? Pause the video now. Okay, we're back. So if we dealt with the right part, then we know that that means we have to be perpendicular. The bisector part means we have to go through the midpoint. So if I was to draw my diagram on there, I need to be at the midpoint of AC, which I don't know, trusting my eyes, looks about there. But then I also have to hit that line at a right angle. So when I go to draw on the line that passes through that point, I want to try to draw on a line segment where it looks, and I'm just going to highlight that green point one more time and show that that is a midpoint, by me hitting at a right angle. So if I was going to label that diagram, then maybe I call one point N and the other point P, like that, and I now have line segment NP. Okay, if we were a little stumped as we worked our way through, then that diagram should help you out, and now we should be comfortable to finish that one off. Okay, I want you to go ahead, try to solve that one. Okay, we are back. So if I'm going to go through and build my equation, I need slope and a point. Well, I do know that my midpoint has to be the point that I cross AC. So I'm going to find the midpoint of AC that will satisfy my bisector. So take the average of my coordinates, -2 plus 3, have it. Take the average up, well, same thing. Ugh, ugly fractions, but we can survive that now. I also have to go through and find the midpoint. Sorry, I just found midpoint. Find the slope of AC because I know that I'm looking for the perpendicular one to it. So I would have my 2 subtract a negative 3 over my negative 2 minus 3. That gives me 5 over negative 5. There's my negative 1. Therefore, I know that the slope of NP must be positive 1. Okay, I get to that point, and I think I should be good. That we should be quite comfortable now to build the equation every time we have slope and a point. So, therefore, my slope is going to equal my y minus 1/2 over my x minus 1/2. I can multiply out. Now, we may be motivated to do a couple things here. Like, we might see the fractions and say, oh, I don't like those fractions. So to get rid of my divide by 2, I want to multiply by 2. I'm not going to. Because if I take a quick peek at that, I notice my negative 1/2, they're going to cancel out. If I add a half to each side, they're gone. Or if I wanted to get rid of one of the minus 1/2, then I'm going to add 1/2 and they cancel out. And so y equals x is the equation of that right bisector. Nice and neat. Okay, I'm hoping that today was pretty comfortable. I hope that we were good with building the equations of lines to things, and that now we're good to jump back in working through some proofs. Okay, your job, do 1,000,000 of them, okay? Get so comfortable at it that you can almost shut your brain off, okay? Best of luck.